Hello guys, I've fixed my mic issue so now I should be sounding a lot louder, which is fantastic. We're starting off today with covalent bonds. We're going to spend 2 lessons learning about this. First lesson is covalent bonds and graphene, or graphite. Next is diamond and putting it all together. So, starting off today, what the heck is a covalent bond? Covalent bonding is the sharing of electrons between atoms. That's what every bond is. You share electrons. Uh, well, in ionic bonding, you trade electrons, but I guess that's still a type of sharing. But in a covalent bond, the electrons belong to both of the atoms in the bond. This type of bonding occurs between two atoms of the same element, or elements close to each other in the periodic table, normally nonmetals, and they share electrons so that each atom can obtain a full outer shell of electrons. This, I cannot overstate the importance of this single sentence. You share electrons so each atom can obtain a full outer shell. Normally 8 electrons they want to have. Okay? We're going to look into this in more detail in a couple weeks' time, but very important. So, what does this look like? Carbon has got 2 electrons in its inner shell and 4 in its outer shell. What it does is they overlap electrons in their outer shell. So in this case, carbon now has 1, 2, 3, 4, 5 electrons. Each carbon has 5 electrons in their outer shell because they're sharing one. And we depict this as just a C, line C, written down at the bottom. So obviously carbon wants 8, not 5. So this is why carbon forms 4 bonds to things. Carbon doesn't just form 1 bond, carbon forms 4 bonds. Sharing is caring. Oxygen is connected to each hydrogen by a covalent bond. So this is in water, and we'll see that here. So here are 3 molecules all with covalent bonds. Carbon dioxide, 1, 2, 3, 4 bonds to carbon. Each bond shares an electron with carbon, meaning carbon now has 8 electrons in its outer shell. Each of these lines represents 2 electrons being shared. Okay? So let's think about that. Oxygen wants 8 electrons in its outer shell. It's got 1, 2, 3, 4 here. 5, 6, 7, 8. Oxygen's happy with 8. Hydrogen wants 2 electrons in its outer shell because it's got its first layer as its outer shell. And so 1, 2, both electrons are in the bond, hydrogen's happy. If we look at carbon down here, carbon wants 8 electrons, and each of these bonds represents 2, so that counts up to 8. All of these are covalent bonds. And covalent bonding is really important in our last 2 types of solids we're looking at. And the first one of these is being covalent networks. And this picture over here is diamond. That's what diamond looks like. So there are 3 types of covalent networks we're looking at: diamond, graphite, and silicon dioxide. These are the only 3 you need to know. So I'm going to post this video on the Google Classroom to watch. It's about graphite. Very cool video. So these are notes you have to take down about graphite. And so you can pause the video now, copy down these notes, and then restart the video. I try to make my notes as short as possible, just covering the key points. But this is what graphite looks like. Each of these balls is carbon, and they're connected to 3 other carbons. So I just say carbon likes to form 4 bonds to get all the electrons in its outer shell. It's only forming 3 here, which means in graphite each carbon is covalently bonded to 3 others in 2D sheet-like arrangement, forming layers with very weak van der Waals attractive forces. New word, we'll cover this in more detail later, between the layers. So these pink these pink lines represents the attractive forces between the layers. Okay? Very weak. Very, very weak. These weak forces can easily be broken with a bit of heat or a bit of friction. And because it's only bonded to 3 others, this leaves carbon with 1 electron that's delocalized and is free to move between the layers. And so it carries a charge. This free electron that can move carries a charge, so graphite can conduct electricity. If you watch the video on graphite that I'll be posting, this will make a lot more sense. I'll also post this one. It's about geckos and them using these van der Waals forces to stick to walls. So this is what graphene looks like, or graphite. Each carbon's bonded to 3 others. And they go on for, they can pretty much be infinitely, not infinite, but in terms of atoms, you got billions of atoms in a graphite sheet. And I think I'll stop there. Diamond will be for tomorrow. What I want you to do is watch this video and watch these 2 others I'll be posting. This one about gecko's feet, and this one about graphite. Alright, thanks guys.